Today, we're going to be hearing from Patrick Lee at Walmart about the great things they're doing with Cassandra there. Over to you, Patrick.
So here, just to kind of give a brief overview of kind of what we do with Cassandra here at Walmart. We've been using Cassandra for a while, but we're kind of the guys that are just kind of hiding in the corner, not very vocal about what we're doing. So kind of our goal now is to kind of get more involved in the community, kind of share a bit more and let you guys know what we're doing. So I'm Patrick Lee, Principal Software Engineer. I've been working with Cassandra here at Walmart for the past 8-9 years. I've been with Walmart completely as a company for the last 26 years. So I've been here for a while. I've done a lot of different things. Not everything's been in tech, but I've been here in tech for the last 15 years. So kind of the agenda for today is we just give a very brief overview of kind of what our Cassandra journey has been, kind of where we started, talk a little bit about where we're at today, talk about what we're doing to make Cassandra easy and usable for our developers, so that they can come get a database and kind of run off and do what they need to do. Talk about just a couple challenges, just touch on those a little bit. And then for the past year and a half, we've been working on migrating everything, getting everything upgraded. So we'll talk a little about that journey and what we've done there and some of the gains that we've gotten from that. So kind of where we started from, I work with two very great guys on the team that started Cassandra here at Walmart at version like 0.6. They're still here. They're still very much involved. I work with them every day. Back in the old days of a bunch of bare metals, getting those stood up on the floor, getting Cassandra installed, upgrades and managements. There for a while, we had several teams kind of all over the place where you've got a group of people over here running a few Cassandra clusters. You got another team over here running a few. You got a little bit of everything all over the place. A lot of DataStax Enterprise that we were running at the time. But in 2015, we really consolidated things down. We created the team that we're on now. We consolidated all the management and all the ownership of Cassandra. We've got one team, and then it was to build that, expand everything out into the cloud. So we had probably 50 clusters or so at the time when we started. And when we go and look at today, since 2015, now we've got hundreds of clusters. We've got tens of thousands of nodes that we manage today, several petabytes of data, millions of transactions per second. And I think what a lot of people would find interesting is that we've deployed this across multiple cloud providers. I will caveat that we do have a talk that's scheduled for Cassandra Summit in December, where we'll go into detail about our journey with multiple cloud providers. So if you're really interested in that, I would say to make sure you join Cassandra Summit and look for that talk that myself and another colleague, Andrew, is going to do with me. So to talk a little bit about our tech stack, these are things that we've published. We use OneOps to do our lifecycle management of our infrastructure, spin up our VMs, handles the deployments of Cassandra, managing the metadata, config files, and things like that. We also have a workflow orchestration tool that we've open sourced called Concord that we use to do the full end-to-end lifecycle, do a lot of triggered repairs, maintenance, and things like that. And for monitoring, we use a Prometheus-based M3 that we have a team that manages that and sets that up for us. So we use that to provide our metrics, our dashboards, and also do our alerting and use that to trigger our healing and automations and things like that. So my very, very, very simplistic diagram. So what happens when a developer wants a database or a Cassandra database for us? So it's pretty simple. It's pretty easy. They go to a portal. They enter in just a few details where they want this to be put. They click a button and it goes. So we use Concord to kind of trigger that, trigger OneOps, handles everything there. Once that cluster is deployed, Concord will then finish that workflow as far as setting up any key spaces, credentials, or anything like that that's needed to be done. And so typically within a few minutes, a developer will have a non-production database fairly quick that they can hit the ground running and start going. Production database takes just a little bit more time because we like to meet and we like to talk through the use case. We like to really, really help with the model and help with particular sizing of a cluster. Really, how big does this thing need to be? We're very cost conscious, as I'm sure most people are. And so we want to make sure that we're not wasting a lot of money by over provisioning. So some of the challenges. So like I said, there's many challenges that we have there. But two of the main ones that I kind of picked were us in dealing with multiple cloud providers. And the next I kind of named developer complexity. And we'll go into details for. So multiple cloud providers. So today we deploy in our private cloud, which is OpenStack. We also deploy in Azure. We've also got deployments in GCP. All of those are vastly different. So the challenges there is, for one, how do you handle, how is maintenance done in each of these? You got to have a very good understanding, and you got to be able to handle that. So for example, in our OpenStack, things are just going to go reboot. I'm okay with that. I'm fine. The way we've got things deployed, where we've got fault tolerance, so I can lose a complete full Cassandra rack, and I should be safe. So that's pretty much handled. But for example, in Azure, things are done a little bit differently. And so Azure has this concept of scheduled events, where when they will do some maintenance, let's say they're going to pause a VM for 9-10 seconds or so. That doesn't, in the past, that hasn't really been a nice, something nice that happens, and people will start to see why did I have some timeouts, or why am I having all these little spikes that just keep popping up over and over? So how do you gracefully handle that? Scheduled events was one thing that we could do, as far as having each individual node listening for when it is scheduled to get some patch. When it gets the patch, or when that maintenance event starts, we could take the VM out of rotation, basically disable, stop Cassandra on it, let the maintenance happen, bring it back up, things like that. So having to deal with, if you're trying to use ephemeral or attached storage, those are all big things. So really having to dig through and understand that. And that took quite a bit of time working with the cloud provider to work through some of the pain points early on that we've had. Other things that we have to dealing with multiple providers is every provider's got their own VM flavors, their own storage offerings. Those VM flavors, those VMs are going to have different types of limits, whether they're going to have IO limits, is the storage have its own IO limits, bandwidth limits. How can I deploy a cluster that spans multiple providers and have it perform about the same or as close to the same as possible? Spent a lot of time digging through, doing a bunch of benchmarks, on different VM flavors, different storage offerings, to get the best performance at the best price, and ensuring that if I deploy something in our private cloud and I deploy in GCP or in Azure, that I'm going to get pretty much the same performance. Or if I can't with the exact same footprint, I know what I need to do, whether I need to scale up a little bit more here versus the other. So keeping up with the changes in the hardware offerings is a fun job. Cloud providers are changing every day. They're offering new, faster storage offerings, or you got to get, we started deploying, let's say 2 years ago, for example, and then now they've got brand new VM flavors with better CPUs that you need to migrate to. So keeping up with that, again, not always sticking with what you know, but also looking into the new things. Maybe there's something faster that's going to save me a little bit more money. So doing that. And I'm sure the number one fun thing of all is hardware failures in different cloud providers. How do you handle that? How do you get details of figuring out what those hardware failures are? If there's a top of rack switch that fails, that we're not going to be able to see that. We're not going to know about that. How that impacts our customers, as far as those Cassandra clusters that we have deployed, and how do we quickly mitigate those? Those are always some very, very fun challenges. I think we spent quite a bit of time, especially early on, working through different failure scenarios and different bugs, using new, especially when we start changing and using new hardware. So when I talk about developer complexity, being a developer, we always think we know everything. We always think that we know best. I don't always know the best thing to do, especially if it's a new platform that I haven't necessarily been involved in. So some developers like to maybe overcomplicate things. So with that, you've got some folks that will like to overtune the driver. I need to set every possible setting that the driver allows me to set. If a node goes down, I feel like I need to have a 5 millisecond retry that just constantly pounds away until it can get a connection. I think I need to have 100 connections per host. So a lot of times what we've dealt with is we've got a lot of our customers, our developers that are using our product, that are just thinking a little too much into it. And so sometimes we can relax those. So one of the things that we've done is we've created a custom client driver that we urge all of our developers to use. Part of that is to provide a consistent set of metrics. One of the big challenges that we've had is you've got developers, everybody's creating metrics. They're all creating their own dashboards. And let's say they've got this graph that says Cassandra response time. And I don't know what that is. That's just a timer between some block of code that says it took this long. But I don't know what their code does. So I don't know if it's issuing one query, if it's issuing 50 queries. And then we get a call that says, hey, the response time's gone up. So having a set of standard metrics, metrics that are provided from the driver, to give us a consistent view of an application interacting with the database, that we can look at both from the application side and the database side, and kind of put 2 and 2 together and say, well, where is the actual problem here? And like I said, with the configuration complexity, try to simplify that. You don't necessarily, in most cases, need to tune every single possible scenario and parameter that you have in the driver. A lot of times defaults work very, very well. In a lot of cases, there's some things that we would like to do. So we tried to make that simple and consistent across the developer community here. Best practice reporting. So a lot of the kind of words that I have out here, data model, number of columns, tombstones, these are all things that developers struggle with every day. Get on a call, hey, I've got this query that fails, and we look and see that, well, they're failing because you're scanning all these tombstones and the query just fails. Or you've got 1,000 tables on this cluster. It's like, what are we doing? Or you got a table with 1,000 columns on it, and it just takes forever. So what we've been working on is consolidating all this stuff. So we'll go out and we'll scan the different clusters, look for all these issues. If these issues haven't already come up to us, where we've been working on and tuning these with the application teams. So we can put all this stuff together. We can provide it into our system, into our developer portal, where these issues and concerns get raised up. We can even be able to kind of limit and say, you know what, before you go put more stuff out here, you've got to take care of some of this tech debt before you really shoot yourself in the foot and you start having problems and then nothing works at that point. So we've got that going on. A lot of times, kind of goes back to what one of the things I'm excited about, Cassandra 5. We spent quite a bit of time tuning tables and data models. Again, even with this, people get, they kind of overthink things. They think, oh, if I change compression, maybe if I increase my compression chunk length, I can compress more data, therefore saving more space. But then you just tank your reads. Compaction strategies, size tiered, works very, very well. A lot of times you overwrite the same data, you constantly update. Maybe leveled is a little bit better fit for your use case. So we spent a lot of time kind of going back and working on these as issues come up. But yes, the data modeling aspect is super important. And that's where, before we like to roll something to production or give a production cluster, I really want to kind of make sure that you've got that data model good. Some things will still kind of slip through, but I tell developers every day that we're not going to be successful if you do not have a good sound data model that has been thoroughly tested before going to production. And you can't test it with just a few thousand rows. You're not going to see your limits at that point. So with all that, Cassandra 4 has been super exciting for me specifically. I have thoroughly enjoyed a lot of the changes that are in Cassandra 4. And we have spent the last just a little over a year and a half getting our entire fleet upgraded from 3.11 to 4. So we went from version 6. When I joined, we were doing a lot of 2.1s. We went from 2.1 to 3.11. We skipped 2.2 and 3.0. And now I think we've only got maybe 2 clusters left that will be upgraded here very, very, very soon. So with that, like I said, actually it's probably like 99.9% of our clusters are upgraded to 4.0x. Majority of them, we've got up to the latest 4.011. But with this upgrade, it hasn't been just Cassandra upgrades. We've been doing a lot of other things as far as JDK upgrades, leaving Java 8, adopting Java 11. We've done a lot of hardware upgrades as well. If you take Azure, for example, we went from V2 versions of VMs to V5s. We've been updating OSs, switching away from CentOS. And all of that together for the over 10,000 nodes that we have, getting those upgraded, that's been a job. It's been a huge job. But we've been adding rings like crazy and doing these upgrades. There's been zero downtime for anybody. Zero. I think we only had one issue with someone that was using a really, really old compact storage still, because you can't really just get rid of it. But that was a very simple fix. Some of the performance stuff. So this is just a very, very early POC that we did. These were just some of the stats. We took a very specific use case that one of our development teams had, and we ran that use case on a 311 cluster as is today. We also spun up a Cassandra 4 cluster, put the same model. The team ran the exact same workload on Cassandra 4. We did that with Java 11. I said Java 17. It was actually Java 16 at the time, but we were testing out ZGC. And it was some pretty interesting finds there. So with the same number of nodes, 6-node cluster, we've seen a lot of stability improvements. For one, with 311, we've got the cluster kind of just maxed out at around 50,000 reads per second. Just kind of just died. We had some nodes crash. It just couldn't, had a lot of OOMs at that point. But with Cassandra 4 testing out Java 11 in Shenandoah, we were able to push that quite a bit more. CPUs on the floor, but the cluster just hummed along very, very well, kept up. We let this run for many, many, many hours, and it just ran. And then we wanted to test out the new functionality of ZGC and see how that worked. And it worked, even though Cassandra 4 doesn't officially support Java 17. Most cases, it seems to work okay. But we saw quite a bit. We saw a little bit more throughput with ZGC at a pretty significant latency reduction there. So Cassandra 4 upgrade alone has been a very significant thing for us. As long, kind of outside of just performance benefits, we've also been able to save on storage, because we've been able to change a lot of things to ZSTD compression that helped us save quite a bit on some clusters as far as storage goes. So we're able to actually reduce some of those cluster sizes overall. Here's kind of like a snapshot of performance. So this top graph is read latency on a particular cluster. And you can tell the green line is before. This is Cassandra 4 upgrade and new hardware upgrade, I should say. So with that, we went from 10 milliseconds down to about 3 milliseconds with Cassandra 4. That's with Cassandra 4, with a JDK upgrade, and with some hardware changes, hardware and OS changes. But the bottom graph is our actual application. One of our application teams, this was their application graph. And this was purely just Cassandra 4 upgrade with a JDK upgrade. And you can see beforehand, it's kind of spiking up and down, going all over the place. And then finally, it just kind of goes down, and it's just pretty flat. So we've seen tremendous improvements in our overall P99 and just P99.9 latencies. They're much more consistent, much flat, and it's been a huge improvement overall. So then we can get into, again, for me being the operator, operational benefits. We went and took, if you compare streaming, so if I had to replace a node, if I've got a node that's on ephemeral storage and I have to go replace this node and it's got 1.5 terabytes of data on it, how long is that going to take me to replace? Well, in 311, it was taking around 2 hours, around 2 hours to replace, especially if it's a leveled compaction table. Then you've got to wait after the node is finished. It's got to finish up all those compactions to rebuild all those levels. So that would take another hour or so. So altogether, for that node to really kind of stabilize and things be really good after that, 2-3 hours. Cassandra 4 with the zero copy streaming, when you can take advantage of it, is the key. It would take less than 50 minutes. And once that node was joined, with it being leveled, like there was no compactions that really had to keep up with. Everything worked flawlessly. And it was a huge improvement. That's really helped us a lot with our scalability, being able to scale up clusters faster. That has been huge. For me, sometimes the simplest things are the best things. Just the ability to be able to look at what specific clients are connected to my cluster easily, honestly, is huge. Especially with this whole where we've been migrating a lot of the hardware. We're building new rings on clusters. People are connecting to the old rings. We want them connected to the new rings. Being able to handle a lot of that stuff. Client stats have been a huge thing. Profile load, absolutely love profile load. You have to go try to find if people are hitting hotspots, things like that. Before you could do top partitions, but I got to know what table to look at and I got to know what key space to look at. Well, if I've got 100 tables, 30 tables, and all of them are being used, I don't want to have to go through those one by one. Profile load has been huge. Being able to just get a quick snapshot of this particular node to see what's going on and compare it with some others. Something as simple as reload SSL. When we've got SSL on a cluster, I don't have to do a rolling restart of this cluster. All I got to do is just go run a node tool command. That's huge. You got a cluster that's 1,000 nodes. I don't want to have to go and do a rolling restart of that cluster. That's not fun. And again, something as simple as enable audit logs. Audit logs are huge. Just even if I don't have them running all the time, if I need to see what's going on, I've got questions from developers. I need to see exactly what they're doing. Being able to just flip this on before I would do enable tracing for just a few seconds or for 50% or so to try to capture things. Audit log is so much easier at that point. So I see there's been some questions around K8s. One of my colleagues, Chad's helping out there. We did do a little bit of work with Kubernetes. There's definitely going to be more to do there. But right now, yes, everything is just VM based. So with Cassandra 4, everything hasn't been always just perfect. But I do say the upgrade to Cassandra 4 was much easier than the upgrade from 2.11 to 3 or 2.1 to 3.11. That upgrade was quite a bit painful. Getting all the SS tables rewritten because there was that performance penalty between there. But our upgrade from 3.11 to 4 has been pretty easy. No adverse side effects. We did run into a couple bugs, and I just called out just a couple of them here that were kind of our worst case scenarios. That first one, like I said, specifically between a few versions, we were running a lot of 4.4, 404s. So therefore we didn't hit this a whole lot. But as soon as we started, oh wait, they released 405. Let's start there. And it was like, oh, wait a minute, that might not, there's something wrong there. That was causing nodes to crash like crazy. And a lot of pending gossip tasks, pending mutations that would just skyrocket. So the worst thing that happened, thankfully it was just on one cluster, was that next one, the schema, where we had an application team that had a map column, dropped the map column, and then added the column back as a blob column. That caused a lot of data corruption and a lot of issues that was not easily rectified. And luckily there was a fix. 4012, as you're probably aware, is not actually released yet. So we'll call that out to be very cautious with that one. But there is a fix in there for that, thank goodness. And then another thing that I happen to notice is running repairs on a bunch of clusters. Running repairs on clusters prior to 407, and noticed there's quite a bit where repairs are taking a heck of a long time. We use Cassandra Reaper to orchestrate our repairs, and repairs that used to run in hours or a couple days to repair an entire cluster was taking a week, 2 weeks. And I kind of had to dig through a bunch of the fixes and realized there's actually several fixes around 407 around repairs. So once we got a lot of those clusters upgraded to 411, a lot of those repair issues kind of went away. Things have been finishing a lot faster. So these are three of the main things that kind of got us. I will say that we did have a few memory leak issues. I noticed when we were running Java 8 with G1 that I did not, those memory leaks were fixed. I'm not 100% sure if Java 11 with Shenandoah was actually just hiding it or handling it better, but we didn't see those issues as we were upgrading the JDKs. So that's really all that I've got. Again, just kind of wanted to give an overview of what we do today, Cassandra, trying to get ourselves out there a little bit more so that the community, you guys kind of know what we're doing. Want to be a bit more vocal. And we've got a talk, like I said, for Cassandra Summit around specifically our multi-cloud journey. So we'll go into details there if you guys are interested and want to know more about that.
Awesome. Well, thanks so much, Patrick, for your expertise here. It's been great to hear from you and to learn what you all are doing at Walmart there. Really, really cool stuff, really interesting. And yeah, it's great to see where you're going with it. Thanks everyone for coming along, and we'll see you next time.